Built-in type, hashing of numeric types. For numbers x and y, possibly of different types, it is a requirement that hash x is equal to hash y, where x is equal to y. See the underscore method documentation for more details. For ease of implementation and efficiency across a variety of numeric types, including integer, float, decimal, dot decimal, and fractions dot fractions, Python's hash for numeric types is based on a single mathematical function that is defined for any rational number and hence applies to all instances of integer and fractions dot fraction and all finite instances of float and decimal dot decimal. Essentially, this function is given by reduction modulo p for a fixed prime p. The value of p is made available to Python as a modulus attribute of sys.hash_info. See Python implementation detail. Currently, the prime used in p is equal to 2 raised to 31 minus 1 on machines with 32 bit C longs, and p is equal to 2 raised to 2 power 61 minus 1 on machines with 64 bit C longs. Here are the rules in detail. If x is equal to m by n is a non-negative rational number and n is not divisible by p, define hash x as m into inverse mode inv mode np percentage p, where inv mode np gives the inverse of n modulo p. If x is equal to m by n is a non-negative rational number and n is divisible by p but m is not, then n has no inverse modulo p and the rule above doesn't apply. In this case, define hash x to be the constant value sys.hash_info.inf. If x is equal to m divided by n is a negative rational number, define hash x as minus x. If the resulting hash is -1, replace it with -2. The particular values sys.hash_info.inf and -sys.hash_info.inf are used as hash values for positive infinity or negative infinity respectively. For a complex number z, the hash values of a real and imaginary parts are combined by computing hash z.real plus system.hash_info.image into hash z.image reduced modulo 2 power system.hash_info.width so that it lies in range -2 power system.hash_info.width -1, comma 2 power system.hash_info.width -1. Again, if the result is -1, its replaced value with -2. To clarify, to clarify the above rules, here is some example Python code equivalent to the built-in hash for computing the hash of a rational number, float or complex. Import sysmath. Let me copy the program and run it. Let's understand here. Import sys, math, def hash fraction mn. Compute the hash of a rational number m divided by n. Assume m and n are integers with n positive, equivalent to hash fractions dot fraction mn. P is equal to sys dot hash underscore info dot modulus. Remove common factors of p unnecessary if m and n are already co-primes, while m mod p. Okay, these are the technical details you can go through. as float as complex. Thank you.